dear students, this is the last part of momentum, which is the special cases of collision. Like this case in example 6, it's about two connected particles. They are connected with a string, and both of them were stationary. And all of a sudden, we take this P away from Q. Of course, it will pull Q with it, and they will move with the string taut. They will move with the same final velocity. But initial velocities, both of them were not the same, because Q will remain, Q was stationary, and you pull P away from it with initial velocity 4. Now let's read the question about connected particles. Two particles, P and Q, of masses 8 kilograms and 2 kilograms. Here is P, it's the bigger. I intend to make it bigger to feel to feel and have expectations of my answers. And Q is 2 kilograms, which is quarter of its mass, are connected by a light inextensible string. The particles are at rest on a smooth horizontal plane, no friction, with a string slack. In the beginning of the story, the string was slack. Particle P is projected directly away from Q with a speed 4. It means the initial velocity of P is 4, and the initial velocity of Q is 0. Find the common speed of the particle. Take care, find the common speed. It means it will be a connected particle system as we took before in mechanics. Connected particles, they have same acceleration, same velocities, but of course different masses and different frictions. Okay, so now you have to find the common speed of the particles after the string goes taut. Take care of this sentence. They have different U's, but they have the same V. Also, some questions you will have this word, coalesce. The word coalesce means they will become one body. After collision, they are stuck. When you find this, it means same final velocity. Okay? If they coalesce, in this case we don't say coalesce because they are attached by a string. Now let's start. We will use the law of conservation of momentum, which is m1u1 plus m2u2, this is before collision, equals the total momentum after, which is m1v1 plus m2v2. First of all, we have to assume the positive direction of velocities. Suppose that we assume it to the right. So I'll write here positive velocities, because I should declare how did I think and how did I assume the signs. The first mass, let's discuss now, the initial velocity is 0. Here initial velocity is positive 4. And here final velocity, what did he want? And the common speed of the particles after the string goes taut. Of course, both of them are going in the same direction, the same V. So everything here is positive concerning velocities. M1U1, it means 2 multiplied by 0 plus M2U2, which is 8 multiplied by 4, is equal to M1, which is 2V, plus M2, which is 8V. It means it is 10V is equal to 8 times 4, which is 32. We divide both sides by 10. So final velocity for both of them, because they're connected, will be 3.2 meters per second. Da-da-da. Part B. Find the magnitude of impulse transmitted through the string when it goes taut. We can consider the impulse as M. We can take the impulse by Q, for example. So it will be M into V minus U. It will be its mass, which is 2, into its final velocity, which is 3.2, minus 0, and it will be how much? 6.4 Newton second. Suppose that, of course, I give an advice. You have to extract the ball from the system with its velocities and its impulse, and as I told you before, make the positive direction of impulse opposite to you. So you write here impulse, the positive direction, like this one. So this final velocity will be positive 3.2. This is if you are concerned in Q. If you are concerned in P, I'll redo it, but with P. Now let's extract the ball, as I told you, from the system. Here is the bigger one, which is 8 kilograms. This is 8 kilograms. Its name is P. P had its initial velocity in this direction, and it was 4. Wait, I didn't write the sign till now. And its final velocity was in the same direction, which was 3.2. So we have to assume that the impulse on P, impulse done by P, should be in the opposite direction of U. This is I, positive, and I put here a negative sign because both of them are opposite direction to impulse. Don't object. You'll tell me, Miss, all velocities are negative. You'll see. We'll get the same impulse. Now let's write impulse done by P, which is its mass, which is 8, open brackets, its final velocity, which is negative 3.2, minus its initial, which is minus negative 4, close brackets. Calculator, negative 3.2 minus minus equals plus 4. It's 0.8. Multiply it by 8, you'll get the same answer, which is positive 6.4 Newton second. These are the secrets of this topic. Now example 7 is the last one. Two particles A and B of masses 2 kilograms and 4 kilograms respectively. This is A and this is B. Are moving towards each other. Okay, towards each other, I have to show that this arrow of initial velocity, these two arrows are opposite each other. Are moving towards each other in opposite directions along the same straight line on a smooth horizontal surface. The particles collide. Before collision, the speeds of A and B are 3 and 2 respectively. This is 3 and this is 2. But I should guess positive direction of velocities. I should guess the positive direction of velocities, like in this direction, for example. Okay? Let's read. The particles collide. Before collision, the speeds of A and B are 3 and 2 meters per second respectively. Given that the magnitude of the impulse due to collision is 7, so it's given that impulse is 7 Newton second. In this case, as long as impulse is given, we have to split the system. Consider each one individually. the velocity of, you want to find the velocity of A after collision, and also we need to find the velocity of B after collision. So now we are not dealing with velocities direction. We need to deal with impulse direction, as we will split the system. Okay? If you are speaking about ball A, assume that impulse direction, the positive in this side, and let's now consider A. If you are now part B, you want to find velocity, final velocity of B, so consider its impulse, which is opposite direction of its. Now we split the system, okay? Impulse is opposite direction of U, and we'll substitute in the impulse formula, which is I equals mv minus mu. I equals mv minus mu. I is 7, and if this impulse going to the left is the positive direction, so initial velocity is -3, and I assume he didn't mention that the reverse direction or anything. He didn't mention after input, what about the direction? But I have to guess. I guess because B is heavier when it hits the smaller one, so the smaller one will reverse direction. They are moving towards each other. This one will rebound in the opposite direction, because this is the smaller. Okay, small and big, when they are moving in opposite direction, like this case, I expect the smaller one after collision will take the shock and it rebounds back. So I expect that the direction of A will be reversed. So I expect V will be positive. And also I expect that the direction of B will be reversed, but I doubt, because B is heavier. I doubt about B. Let's assume that they are coming opposite to each other, and then both of them will reverse direction. Anyways, if we will know whether our assumption is right or wrong when we find the sign of the final answer of V. Now, positive direction of I to the left, so U, it's -3 and V is positive. How much is M? It is 2 into V minus 2 into -3. So minus minus equals plus 6. So 7 minus 6 equals 2V. It means 1 divided by 2. So velocity of A will be 0.5 meter per second. It is positive half. It means that our assumption that A will reverse its direction is correct. So about B, we assume that the positive direction of B to the right, which is opposite to U, and U will be not 2, it will be -2. And we'll assume that it will also be reversed, so the positive direction of V is the same like impulse. And now let's write about B. The impulse here equals mv minus mu. As usual, impulse is the same, which is 7. A on B, B on A, both of them are 7. The mass of B, it's 4. Into final velocity, it is positive. Minus the mass of B, which is 4, into the initial velocity, which is -2. And minus minus equals plus 8. 8 will cross the bridge and change the sign. So 7 minus 8 will be -1. 4V, it means the final velocity of B is -1/4. Okay? It means that the direction of motion of A is reversed and the speed is 0.5 meter per second. And the direction of motion of B is unchanged and its speed is 0.25 meter per second. Here you have to comment that the direction of B is unchanged. We assumed it will reverse direction, but it's negative velocity, so it will not change direction. Shall I repeat the question, miss? No, don't repeat it. It's enough to just comment. Is unchanged with speed equals quarter meter per second. This is the comment you have to write concerning B. Concerning A, you write this comment. The direction of A is reversed and its speed is half meter per second. That's all for today, and see you in the next video for work, energy, and power. Thank you. Bye-bye.